Okay, so the first question we have here is to decide whether or not each of these is a function. So we have to take this vertical line that we have and slide it across our function to see if we ever hit more than once. We don't want to hit more than once. If we don't, like if you look right here, we're only hitting one time. That means we passed the vertical line test, and we can say in this particular case that yes, it is a function. Then we can take this line and we can check to see on our next function. So we're going to start to slide it across, and you can see right here at this point, right here I'm hitting the function, right here I'm hitting the function, and right here I'm hitting the function, which means I have failed the vertical line test. So no, it is not a function because it failed the vertical line test. So if we try one last one here, if we grab this vertical line and we're going to slide it across, sliding our words with it, I'm not really sure why, but as we slide it, we can see in every single case, we're only hitting that function one time. So that very last one, we can say, yes, it is a function. So what I'd like you guys to do now is you are going to pause the video, and on your study guide, you're going to do numbers 1 through 4. So pause the video, do numbers 1 through 4. Now we need to decide if each graph represents a linear or a non-linear function. So we need to remind ourselves what it means to be linear is that your function looks like a straight line. So this guy over here, he's not a straight line. He's curvy as can be. So we know he would be non-linear. This next graph, which is a lovely straight line, we know that this function would be linear. At this point, I'd like you to pause the video and try numbers 5 through 7. This question asks us to decide if each relation is linear or nonlinear. There's a couple different ways we did these problems, but every single time we looked at this to decide, we made a table of values. So we're going to go through and we're going to fill in each point. So we have 2, -2, -1, 0, -4, 1, -7, 3, -10, 6. All I did was take all of these x values and put them in the x column, all of these y values and put them in the y column, and make sure they're matched up with each other. Now we're going to figure out what the jump is from here to here. So remember, we do bottom minus top. That means we went down 3. Here, we do bottom minus top. That means we went down 3. Here, bottom minus top. We went down 3. And we continue that pattern, and we can see that we went down 3 every single time. So we check over on the right-hand side to see what happened on the y's. And if we do bottom minus top, we say we went up 2. And then bottom minus top, we see we went up 1. So we can see here that the change right here is not constant. So change is not constant. As soon as that happens, we are able to say that this function is not linear. It would have had to remain constant all the way through that in order for it to be linear. So now I'm going to have you guys pause, and you're going to do numbers 8 and 9 this time. Deciding if an equation represents a linear or nonlinear function was done by looking at 3 different factors. So in order to be linear, you had to kind of follow 3 rules. The exponents of x and y, so the exponents of x and y had to be 1. So a plain old x, a plain old y was okay, but something like x squared would not be okay. We also had a rule that x and y can't be multiplied together. In order to be linear. and we had a rule that x and y couldn't be in a denominator. So that means in the bottom of a fraction. They couldn't be in a square root symbol, and they can't be in an exponent, like a 2 to the x. That would not be okay. An x in there would not be okay. Or if I had something like 3 over y, where that was in the denominator, that would not be okay. So if we look at the two up here, we have to decide linear or nonlinear. This guy I know is nonlinear. And the reason I know that is because x and y are multiplied together. So we can say x and y are multiplied. That would be our reason. For this other problem right here, we have a fraction. So sometimes people start to get freaked out by the fraction. This y has an exponent of 1. It's not in a square root. It's not in the bottom of a fraction. This x right here is in a fraction, but it's not in the bottom, which is perfectly legal. So we would say that this guy right here is linear. So at this point, we'd like you to pause the video, and this time you're going to do numbers 10 through 13. All right, so now we have to remind ourselves of how to find x and y intercepts. A reminder, an x-intercept is where we cross the x-axis. This guy right here is the x-axis. And a y-intercept is where we cross the y-axis. And that's this guy right here, the vertical line. So this point over here is on my x-axis. So I know that that is an x-intercept. So coordinates of that point right there, 3 for the x value, 0 for the y value. The other point on here, this guy right here, that's on my y-axis. Remember, my y-axis is this one that's going up and down. That point over there is my y-intercept. And my y-intercept, if I look at the coordinates, we have 0 for the x-coordinate and 2 for the y-coordinate. It's a y-intercept, it has a y-coordinate. Now I would like you to pause, and I'd like you to do number 14 and 15. We've been asked here to find the x and y intercepts of this equation. So I've put a reminder over here that to find the x-intercept, we plug 0 in for y, and to find the y-intercept, we plug 0 in for x. So as a reminder of how this works, we take our equation that's already written, the 3x minus 4y equals 24, and I'm going to plug 0 in for y. So I'm going to have 3x minus 4 times 0, I'm plugging that in for y, equals 24. And now I simplify it. 3x equals 24, divide by 3, and I get x equals 8. My x-intercept is 8, and then remember our y-coordinate was 0. On the other side, if I have 3x minus 4y equals 24, and I'm plugging 0 in for x this time, I'm going to plug my 0 in for x, minus 4y equals 24. This gives me negative 4y equals 24. Don't forget that negative sign. A lot of people forget it. We divide both sides by negative 4, and we get y equals negative 6. So for my coordinate, my y value is negative 6, and my x value was 0. We want to make sure we're writing them as ordered pairs for our intercepts. Now I would like you to try number 16 and 17. Not much to do on this page. Remember, when we are reading our line, we're reading it from left to right. So for this first one, if I read from left to right, the line is going uphill. So it has a positive slope. Left to right, I'm going downhill. So I have a negative slope. Remember, when my line is horizontal, I have 0 slope. The top and bottom of the Z are horizontal, just like that line. And when I am a vertical line, my slope is called undefined. And if you remember, the sides of the U are vertical, just like that line is. Now try numbers 1 through 3. Each time we get to a new slide, we're getting closer and closer to the material we were just working on, so you guys should be remembering more and more of this. To find our slope from a graph, remember, if we have 2 points, we start at the point on the left-hand side and we figure out how far up or down we went and how far left or right we went. So we're looking to find our rise over our run. So in this case, if I start at this point on the left, I go up 1, 2, 3 units. I went up, so my rise is 3, and then I go to the right 1, 2, 3, 4, 5, 6 units. So my run is 6. I simplify that and I find out my slope for this particular graph is 1/2. This next one is a little bit different because it doesn't have points on it. So I actually have to pick some points that are going to be friendly for me to use. And so I'm going to choose those 2. If I start at the one on the left, when I calculate for my rise over my run, in this case, I had to go down first. So I'm going to have a -1 for my rise, and then I went to the right 2 units. So run is 2. There is my slope for this, because that guy can't be simplified at all. Please try numbers 4 through 8 in your study guide. We were just doing this on Monday, so this should go pretty quickly. You're being asked to calculate the slope of the line that goes through these 2 points. So remember, we made a table, x, y, we filled in our 1 and our 3, our 4 and our 5, and then we had to figure out what happened from here to here. So if we do bottom minus the top, we get, sorry, my pen isn't writing, up 3. And if we do bottom minus the top again, we get up 2. So our rise over our run, remember rise is the y's, we're going to get 2 over 3. I would like you to try now numbers 11 and 12. This problem is asking us to find the slope and y-intercept of each line. So if you remember, if I'm in the form y equals mx plus b, my m, my number next to my x, is always going to be my slope, and my constant, my number without an x, is always going to be, in this particular case, my y-intercept. So looking at the equation we have, the number that's attached to x right here, my slope, is going to be 4/5. My other number, the one not attached to x, this 3/2, is going to be my y-intercept. I purposely switched things around here so that you'd have to stop and think. It's the number attached to x that will be your slope. The other number will be your y-intercept when y is alone. You are now ready for numbers 1 through 4 in your study guide. Graphing a line, given it in slope-intercept form, might be one of the most important things you learn in the class this year. So if we read this, our slope tells us that it is -2/3. It's the number in front of x. Our y-intercept tells us that we are at -9. When we go to graph this, the first thing we do is we go to our y-intercept, -9, and we put a point. Now my slope tells me from this point to go down 2 units and to the right 3 units. The issue with that is it seems like my graph runs out of space. Don't be afraid, do it anyway. If I go down 2 units, I can just kind of put a little marking there, and then to the right 3 units, to give myself an idea, I know that that second point is going to be right there. So I now connect them with a nice straight line, and that is the graph of that line. Some might even say from this point, after we go down 2 and right 3, we could then go up 2 and left 3, and we could have put a couple more points on here. Then when I connected them, my line would have been a little bit better. All right, try numbers 5 and 6. 5 and 6 on your study guide. Only a couple more slides to go, guys, and we'll be done. So we've got our slope, which is equal to 4. We've got our y-intercept, which is equal to -6. We're being asked to write our equation in slope-intercept form, which is y equals mx plus b. So where it says m, we're going to replace that with our 4. Where it says b, we're going to replace that with our -6. Try numbers 9 through 12. They should be super quick and easy. With this question, we're being asked to put the last couple concepts together. So we're asked to write an equation of a line in slope-intercept form. That means we need two pieces of information. We need to find the slope, and we need to find the y-intercept. So I've got a y-intercept right here where I cross the y-axis. I'm at -2. In order to find the slope, I need 2 points. So if I start at this blue one, which is on the left-hand side, I go down 1, 2, 3 units. So I went down 3, so that's a -3, and I went to the right 1, 2. So my run is 2. Once I have my slope and my y-intercept, I can write my equation in the form y equals mx plus b. I fill in the -3/2 for m, and I fill in the -2 for b. Remember, your y-intercept is always your value of b. So I would like you now to try numbers 13 and 14. We're being asked here to write our equation in slope-intercept form. In order to write an equation in slope-intercept form, your goal is to get y alone. So in order to do that, we are going to, in this case, subtract 2x from both sides. Once we do that, we're left with -3y equals 9 minus 2x. Do not lose this negative sign. A lot of people lose that, and that causes them to make mistakes as they go. Now, in order to get that y alone, we're going to divide by -3, divide by -3, divide by -3. Everybody gets divided by -3. These guys cancel, leaving me with y equals 9 divided by -3 gives us -3. The -2 divided by -2 right here, divided by -3. A negative divided by a negative is going to give us a positive 2/3 x. So we were able to get that alone. Now, if we had to, we could tell you that our slope was positive 2/3 and our y-intercept, that other number, is -3. So once we transform it, we're able to answer questions from it. Okay, so now I would like you to try numbers 17 and 20 from your review packet. Woohoo! We made it to the last slide. I don't know about you guys, but that makes me excited. So we're asked to write here the equation of the line that goes through these 2 points. So if you guys remember, what we were doing in class is we had to do 3 things. First, we had to find the slope. Second, we had to find the y-intercept. Find the y-intercept. And lastly, we had to write the equation. It was a 3-step process. So if we go through and do all of those things, to find the slope, we made our xy chart. We fill in the 4, 2, and the 2, -3. So from 4 to 2, we went down 2. From 2 to -3, we went down 5. So my slope, if I did rise over run, is going to be -5 over -2, which will give me a positive 5/2. To find the y-intercept, I have to pick one of these 2 points. I'm going to pick the one that has 2 positive values, and I'm going to label it xy because I'm going to use it, and that will help me. So I'm going to write y equals mx plus b. So my y value that I'm going to use is this one from up top here. The y value is going to be 2. The m value is my slope from over here. So I'm going to fill in the 5/2 times the x value is coming from up top. That's 4. And then I have plus b. I have 2 equals, remember, multiply the tops, multiply the bottoms. I end up with 20/2 plus b. 2 equals 10 plus b. I subtract 10 from both sides, and I find that b is equal to -8. So now I've got my m, I've got my b, I can write my equation. Y equals 5/2 x minus 8. There's the equation of my line. I would like you guys at this point to do numbers 21 and 22. And those will be the last problems that you have to do.